Statistics is a branch of mathematics concerned with data or numerical information. And this numerical information is gathered and it is arranged or organized in a certain way. Formulas are brought to bear on the information, and often predictions are made using the results of the formulas. Well, we're not going to get into all of that, but we are concerned with how the information is displayed. And displays of information in statistics are accomplished by using graphs. And we're going to look at a number of different kinds of graphs. The first one is called a pictograph. Now, to set up the situation involving a pictograph, suppose that this question was presented to a number of people. What would you like to have with you on a desert island? And there were 600 people responding to this question. And here is the result, let's say. We have some responded with, I'd like to have music. Some would say, I'd like to have my parents with me. Some say, I'd like to have a computer, books, or TV. Now, pictographs are characterized by having little pictures to illustrate some number of respondents that fall into a particular category. And here we're using, and we kind of have to be a little bit lenient with your opinion about art, because I am drawing these little figures. These are supposed to be little palm trees. Pretend that they are little palm trees, please. My ability at drawing little things like this is somewhat limited, as you can see. But in pictographs, generally there's a picture involved with a number of respondents, and the picture corresponds with some number, and somewhere on the display of the pictograph that information will appear. And here, each of the palm trees represents 30 respondents. Now, so it's pretty easy then in this pictograph, and this is a really important characteristic of graphs, that you want to be able to see certain aspects of the information very quickly. And here we can see just by the number of palm trees that are the greatest and the least, for example, that will give us the largest number of respondents in a particular category and the smallest number of respondents in a particular category. So we can see that very quickly. The actual numbers involved require a little bit of calculation. For example, for the television respondents, we have, let's see, 30 is associated with this palm tree, 30 with this one, so that's a total of 60. Now we could write the total for each of these groups if we wanted to do that, and then maybe a problem would ask us to do that, and it's pretty easy to do. Now notice that there is a complete palm tree associated with every one of these figures. Every one of the figures I've drawn is a complete palm tree. But it's pretty unlikely that each of the categories would be a multiple of exactly 30. For example, suppose there weren't, let's see, 60 respondents here. There were 45, let's say. So that's 30 and then 15, you see. But 15 isn't represented by a full palm tree. So it might turn out that in some circumstances we would have to have maybe like a half a palm tree to stand for less respondents than the full number associated with the picture. So kind of keep that in mind as you look at pictographs in the future. Okay, let's answer some questions having to do with this graph. Now, a lot of times, as I say, we have to look at the graph and we have to make some calculations of one kind or another. And the problem that's associated with it will tell us what we have to do. Let's see. Books was the response of what percent of the respondents? Books was the response of what percent? What percent? Well, gee, we studied percent before. And this is a question which has a lot to do with the percent equation from our earlier study. And we can see it in a number of ways. One way is to just kind of paraphrase the sentence that we see here and paraphrase it in such a way that we can see through this as a true percent equation. For example, I might say, what percent of the respondents was those that selected books? You see, what percent of respondents was for books? You see, so that's the idea. I'm just kind of abbreviating a little bit, but it allows us here to look at this and then translate this into a mathematical form. So what percent? Gee, that's the unknown, so it would be something like N, or N percent. Of means times. Respondents. Well, gee, that's the total number of respondents in the entire study. We were told that that was 600. So it's what percent of 600 was, that's a verb form, you see, and the equal sign goes in that position. The respondents for books. Well, we would have to go over and look at the number of respondents for books. Let's do that. Let's slide back over here and look at the number of respondents for books. Well, there are 3 figures associated with books. Each one of them is 30. So 30, 60, 90 respondents were for the books. Let's go back over here and put that information in. So we put 90 here, and now we'd like to solve for N. Now remember, in order to solve for N, we want to isolate the N on the left side of the equation, and so we'll do that by dividing on both sides by 600. It allows us, in doing that, to cancel the 600. So on the left, we have 600N, and we'll divide by 600. And if we divide on the left by 600, though, we have to divide on the right by 600. So we have this, and the 600s cancel as expected, so N is equal to this fraction. Now, remember that we want some percent here for N, so we're going to write this as a decimal, and it turns out to be this decimal, and that decimal turns out to be 15%. So 15% of the respondents selected books. Here's another question associated with the same problem. What is the ratio of the number of respondents requesting a TV to the number requesting a computer? Now remember, we studied ratio before, and I'm showing this problem because I want you to know that there are a lot of different forms that equations can take in dealing with pictographs. That is, we can have a question associated with any of the studies that we have had previously. So we talked about ratio previously, and we know that a ratio implies a fraction, or that's one way to illustrate it. And when we talk about ratio, the ratio of one thing to another, the very first thing that follows the word ratio is in the numerator of the fraction, and the second item is in the denominator. So it's the idea that we see ratio, and now we know we have a fraction, the ratio of the number of respondents requesting a TV to the number requesting a computer. So it's the number for the TV in the numerator, the number for the computer in the denominator. So it's like this. It's TV over computer. And then we would look back over and check out the number of respondents associated with these. I'm just going to glance back over. We know how to do that at this point, I think. But for TV, there were 2 little palm trees, and that corresponds with 60. And for computer, there were 1, 2, 3, 4. Now that's 4 palm trees. Each one is 30. So 4 times 30, you see 120 associated with the idea of computer. Then we would reduce the fraction to 1/2, and so the ratio is 1 to 2. We could also illustrate that ratio like this, as 1 to 2. Another type of graph used in statistics is called the circle graph. It's also called a pie graph sometimes, or a pie chart, and we kind of see why by looking at the graph. Well, regions of this circle represent quantity, and it's really easy to tell what the largest and smallest quantities are and how they compare with one another very, very quickly in looking at a circle graph. Well, this happens to be a graph associated with this information. It is the distribution of advertising dollars for 25 companies. And let's say the total is $17.5 billion. $17.5 billion. This is a problem that's in your textbook, and I've changed the total just a little bit. You might notice. So our answers when we do problems are going to be just a little bit different as well. In the book, the total is $17.8 billion. I made it $17.5 billion. All right, at any rate, what we're seeing here is that broadcast television is 60% of that total. So by far, broadcast TV advertising is the most prominent kind. And we see here magazines 16%, newspapers 13%, cable TV 8%, radio and and outdoor advertising consume the other part of the total. Now, although it's easy to see a lot of relationships here, sometimes we need to figure a few things out. And do notice that percents are used in this particular circle graph. Sometimes, rather than percents, a certain total amount is used. You see, we don't have an amount of dollars here in each part of our graph. We have a percent of the total as illustrated here. But sometimes the amounts are given here. Well, anyway, we can answer questions such as this. How much money was spent for magazine advertising? You see, according to this, it's written as a percent. And so we have to translate that idea of a percent into some kind of quantity. Now, the percent associated with magazine advertising, as I look back over here, is 16%. So we're saying what quantity, what advertising number is associated with that 16%? Well, remember, percents often contain a hidden operation, and the hidden operation is multiplication. So we're saying that magazine advertising is 16% of what? You see, and it's 16% of the base or of the total amount of advertising. So what we're figuring out here is 16% of the total of 17.5 billion. You see, or it is 0.16 times 17.5, which turns out to be 2.8. So it's $2.8 billion is the amount spent on magazine advertising by these 25 companies. Suppose in the same circle graph we want to find the ratio of the advertising dollars spent in magazines to the amount spent on cable TV. Now, magazines to cable TV. We know that with ratio we're going to make a fraction, and we're going to try to reduce the fraction if we can. But it might come to mind that we might think, well, gee, do we need to use the actual numbers of advertising dollars here? That is, do we need to figure out the actual number of dollars like we did on the previous problem for each component of the ratio, or can we use the percents involved? Well, it turns out that either of those would be fine. For example, and I'll show you both ways here to make sure we understand this, that if we want the ratio of advertising dollars spent in magazines to the amount spent on cable TV, we might do, let's see, now magazines appears in the numerator, and I'll emphasize that here. So we want the magazine ad dollars in the numerator and the cable TV ad dollars in the denominator like this. And the percents associated with these are, well, I'll look back over here for magazines, it's 16%. And for cable TV, it's 8%. And it's pretty easy to see that the numerical ratio, the 16 over 8, is just 2 to 1. 8 into 8 goes 1, 8 into 16 goes 2. So this is just a ratio of 2 to 1, which we can also write like this if we want to. Now, to verify that we get the same result, whether we use actual ad dollars or whether we use percents as we did here, let's go off to the side and make some calculations. For the magazines, now we did this calculation earlier, but it's 16% of 17.5, or 16 hundredths times 17.5, 2.8 billion. For cable TV, 8% of 17.5, or 8 hundredths times 17.5, 1.4 billion. So if we're using the actual numbers here, the ratio of magazines to cable TV in advertising dollars is 2.8 to 1.4. And once again, it reduces to 2 over 1. Now, to accomplish the reduction, here's how that's done. You're just taking both numerator and denominator and dividing by 1.4. Divide this by 1.4, you get 1. Divide that by 1.4, you get 2. So it turns out the same whether we use the percents in both parts or whether we use the actual ad dollars in both parts of the fraction.